Hey there, Russ here. Welcome back to the shop. Okay, today I want to show you the latest thing I just finished. Basically, it's a Ryobi battery powered power outlet. If you remember, earlier this year I made this one. This was a pretty good sized monster. It has 110 here. Just plug it into the 12 volts that I have here. So if I put a battery in it, I instantly have oh, I instantly have 19.4 volts. Don't know why it was giving me trouble getting into place. Anyway, so if I turn this on, I now have power here, 12 volts here in this area. Now this is two USB ports. Anyway, you can go back and see where I built this thing, and it was okay. It's a little bigger than what most of these power boxes you see, but I also have a 200-watt inverter here that I can plug in to here so that I can get 110 volts out of it. Not a lot of power. I think that this thing is rated at around gee, I don't even remember anymore, but probably somewhere less than 10 amps for sure. So I know this thing isn't going to be a big powerhouse, but it's a handy little fella that you can hook up. If you lose power, you want to use your computer still, just grab a Ryobi battery, this box, and plug it in there. If you have a 12-volt adapter for your computer, you can plug it in here. So it's just a little power outlet to give you a utility. And I've been pretty happy with it. I've done a couple of things to it since I first built it that I haven't ever talked about before. But why we're here is because I built another version of something similar to that that has a couple of different capabilities that one didn't have. And that's this little fella right here. So first thing you'll notice, definitely a lot smaller. I decided when I built that one, I thought I was going to put all sorts of different types of plugins in, and that's how I imagined it. But I've since then realized that I only need some banana terminals. Plus, I use a 12-volt plug-in here. And then this is just a little USB adapter for it that I can plug in here. So I quickly have DC volts here, anywhere from 20 volts down to 4 volts. This knob here is the adjustment knob for the amount of voltage. The constant current is going to be whatever the voltage is. You don't control the amps on this thing. You're only controlling the voltage. So, and most of the time, if you're using it, as long as I know how many watts this thing is pulling, I know that this thing will not buckle under it. You'll have no problem using it. But just like that one, yes, it has limitations. This one has a 5 amp rating, actually an 8 amp rating, based on the module for the voltage control. But 5 amps under heavy use for a long time. But they say you can go to 8 if you use a fan to blow across the heatsink that's already on there. So I did install a little fan right behind where that heatsink is, within a ½ inch of it, just a little small, about a 2-inch fan or so, whatever it is. And I put it on a switch. So if I read my amps here, this has both the voltage and the amps that you're pulling while you're using it. If I'm going to be pulling more than 5 amps, I just turn that on. That turns the little fan on, and that keeps everything a little cooler then. I still want to drill some holes in this. I haven't done it because I haven't figured out where I really want to put them. I also may put a couple of little block panels in here so that it helps deflect that flow of air, so it pulls in one spot and pushes the air out at someplace else. So that's why I haven't drilled the holes yet, because I don't know for sure how I want to handle that. But it does work. It works perfectly, and I really like it mainly because of the size. And again, just like my other one, if I want to use this for 110 volts, I just grab any inverter that runs on 12 volts, and I just plug it in here. And now I can turn it on to get 110 volts. So to use this thing, you just, after you plug your battery in, the on and off switch, I turn it on, and I actually can control, right now it says 16.5, and if I turn that down, I can turn that down more and more. Let me get a little closer here. I can turn this down to just about anything. So by controlling this, I don't like this knob. I have to tell you, it's not quite as sensitive as I'd hoped it would be, but that's okay. Most of the time, I'm just going to set it between 12 and 13 volts somewhere. It doesn't matter where you put it. It's going to stay stable at that. So then, because you're pulling it off of 20 volts, so you're just reducing it down. This thing has a built-in buck converter on the voltage control. So now that we're running, let's turn that up just a hair more. So now when that's running, I turn this on, and now you can see how many amps this thing is pulling just at idle. But I now have, because this is turned green, that tells me that I have 110 volts here, up to 300 watts. So that quick and easy, I turned this thing from a Ryobi battery to 110 power outlet, and it's very compact and light. So this thing actually is a little better than this one in some ways, than that first one I made. Plus, that one only gives you 12 volts or the 110. Well, and the USB ports that I put on it. If you want to do something more than that, you'd have to get something out special. I can control, if I'm only working with DC volts on this, I can control where I set my voltage so that when I tap into it, I can run this, like I said, even at 5 volts if I wanted to do something special with that. So it's a handy little power box to have. Very basic, very similar to using this, only with this one I have a much different buck converter on this, and a little more elaborate because it controls both the constant current and the constant voltage. So, but this is more of a utility type, and it works real well. Like I said, if I go over 5 amps, if I turn that on, that fan, you can see it kicked in. If I turn that off and then it goes to 0, that means that fan at 16 volts, 16.5 volts, it's pulling 5 milliamps. So it really should not run on less than, it should run on no more than like 12 or 13 volts. And it's such a small amount of draw that it really isn't going to affect the life of that battery too much. But when I don't, unless I'm pulling some really heavy load, 5 amps or above on here, I won't even use that switch. I won't be needing to turn the fan on. But if it's on, it's not going to be a big deal for draining your battery down. When you're done, you just take the battery out, turn it off, and put it up on the shelf till you need it. It's really kind of a nice little unit. Let me show you inside real quick. I'll show you a wiring diagram of this, so that if you want to make something similar to this, it's not hard to make, and the only components you really are going to need, let's pull the diagram up and let's go over that. Then you can see the components that you're going to need. So, this is my board. Give me a second. There we go. Just to keep that from moving. So, right here is our diagram. Let me zoom in just a tiny bit so that you can see this a little bit better. There we go. Okay, so we have our major component. This is the battery. In this box, we have a voltage regulator with a knob on it. That's this piece right here. Then we have, coming off of that, we have our battery power going into here on the positive side, and then it comes out on the positive side, and it goes to the switch that controls the fan, and it also powers out and powers this outlet, and it powers this outlet here. On the negative side, I hooked up the amp meter directly to the battery hookup. So the negative coming out of the regulator, the red wire for the amp meter, the red wire goes to the negative side of the volt regulator, and the black wire goes directly to the negative on the battery. So, and then again, you don't need this black wire here, but on your volt amp meter, your red and your yellow, just put it to the intake side of here. Then you'll see the voltage that is regulated rather than the voltage of the battery. You don't really need to see the battery voltage which is one of the things I did on that one, is I just monitored the battery voltage. But on this one, you don't really need to, because really you have this fuel gauge on these things anyway, right there. And as you can see, I have 3 bars on this one. This one is starting to get discharged. But but while you're using it, you'll be able to monitor your voltage and how much amps it's using when you hook it up this way. Anyway, so your major components you need is a pair of banana connectors. You need a 12-volt cigarette lighter type plug-in. You need one little switch, and you need a small 12-volt fan that runs. And like I said, I got one of those little 2-inch or so. I'm not sure what they are. They're pretty cheap. This whole thing right here, I have probably about $10, $11 wrapped up in it. And then I bought this inverter for about $19. So it's not a lot of money to wrap up, but it's a nice little outlet to have. And these are the major components that you have. So you really only need the fan, the switch, some kind of voltage regulator with a knob so you can adjust the voltage. You could use a standard buck connector and just use the screwdriver like I did on this one when I made this power supply here. And I do this one, those 2 knobs are adjusted with a screwdriver that I keep by it. You could do that with this one too. I just wanted the convenience of a knob so I could just adjust it real easy to the volts that I know I want to pull from it for whatever I'm using it for. And then I can just start using it and don't have to touch anything again. So it's a very useful item to use, but this is all the components you need. So anyway, if you have any questions about any of this, about where to get any of it, let me know. I'll put a link to the, let me zoom that back out. I'll put a link to the module that I actually bought. I think on Amazon I paid around $8 for it, if I remember. Maybe it was $7. So it was pretty cheap. And it's a lot cheaper than a regular buck converter because you're only controlling the voltage. It doesn't have as much electronic complexity. You can put any kind of buck converter that you would want on this. I just went with this one just for the convenience of a knob. So you can look around, and 5 amps is probably not a bad ratio to have. You can get up to 550 watts at 110 volts that way, if you think about it. This thing will actually, I think I can pull it, but I have some battery tests. I am really going to be doing some things. This is just the start of what I kind of want to play with, using Ryobi battery for getting accessible portable power for other uses. I can take this by putting a battery in here and using the inverter. I could plug this into my computer and run my computer for several hours, I suspect. That's one of the tests I want to run, is try to run my computer off of this battery pack and see how long it lasts and see how well it does. So once I've done all these tests that I'm going to be doing, I'll let you know kind of what you can expect from a Ryobi battery, because my thought is that I use the Ryobi batteries in my shop all the time. If I need to use portable power for some reason, because mostly around here, it's because the power may go off. And for a couple hours, I may be having to use other methods to run my network and run my computers. So, which is the only thing I probably would have to run, maybe a couple of lights. So keeping some batteries like this around, they now get several uses. So my plan is to build a few accessories that run off of the battery that I would use instead of running on shore power, on the power from the grid. So, because when they force me off grid, I don't have any choice. I got to find another way to do the things I want to do. So I think I can take these batteries and really turn it into a nice conversion to go between on-grid and off-grid by plugging several of these in and using them in strategic places to run the things that I need to run the most. So right now I'm trying to work on, after this is done. I think it's a great success. The only thing left is for me to drill a couple of holes in here. Let's look at the inside real quick so you can see what kind of a mess I got there. But it's really not that big a deal what we have. And then we'll call this video about done. So when I take this off, the receptacle, obviously the Ryobi battery receptacle, is attached to the lid part. 2 wires here, soldered on, and this is where all the rest of the components, the rest of the components are right in here then. This is the knob, and this is the module right here. The PCB is right here. This is the heat sink. Can I get this a little closer? So I have the heat sink on this module right here, and the knob is right here. So this fan is just, like I said, a 1/2 inch or so away from the heat sink. So when I turn the fan on, the air is blowing directly onto that heat sink within a 1/2 inch of it. Now, most of the stuff I soldered the connections on. This is my outlet here, and right there, down in there, is where my 2 connectors are for these 2 connectors. So all the wires come together in this area here. Nothing really fancy. There's nothing really to show. I did put this on a lever connector instead of soldering. That way I can actually take this piece off completely and separate these 2 pieces from each other if I need to. So that's why here I have 2 other connectors where there are more than 4 wires going to each of these. Therefore, I just went with this instead of soldering things together. In case one of these components has to be pulled off, it would be a lot easier to just unlever it. So for now, I'm into using these for some of the things I do, but I do solder a lot of my connections and just put heat shrink on them to make my connections. But that's this whole thing in a nutshell. It's pretty simple, straightforward, and like I said, it works really well. Now, one thing I've learned from this is that I can now do a 300-watt inverter using a Ryobi battery. But now I'm starting to think, after some of the testing I've done with this battery, I actually have found that I pulled 11.5 amps off this battery from fully charged to empty without damaging the battery or getting anything of any excessive heat. So this thing pulled 11.5 amps at 20 volts without any problem. So if I can pull that kind of power from this battery, what can I do with 2 batteries? Or a bank of them, 3 or 4 or 6. I could set up a nice little powerhouse using my Ryobi batteries, so I can have a power that's as good as that's almost as much power as maybe the Jackery 500 would have by the time I got done in amps and in watts that you can pull from it. So I'm really interested in trying to double this up. What I think I'm going to make next in my Ryobi battery power stuff is another one similar to this, only I'm going to use 2 batteries that can plug into it. So if I plug 1 battery in, it'll be like using this one. But if I plug 2 batteries in, I'm hoping to find a knob, a regulator that I can get bigger amps out of. And by hooking up 2 batteries, I can actually get a lot more power from a little power box, from these OTB power boxes that I've been building. So stay tuned for that. Right now, this week, I'm actually working on my doggy door right back here. It came apart. She torpedoed through there like she always does, the one on the house, and this is all that's left of that silly thing now, man. She busted that thing big time. So anyway, at this point, I have to make a new one, and the one I bought is actually a couple inches wider, so I got to rebuild the frame and everything. That's what I'm working on now to get doggy door back in over there. As I mentioned the other day, I ordered the door and I've been waiting for it. And believe me, everybody else is really anxious to get that doggy door in, so that's my high priority now to get it done. And I'll show it to you when I get it done. There's nothing special. I did a doggy door for both of them before, and I showed you this one. I have a video on it. So if you're interested in that, let me know, and I'll give you a way to find it. Or you can just put doggy door in my channel. Go to my channel and do a search on the channel and on the doggy door, and that will come up. So it's kind of interesting way of putting the doggy door in, using into a sliding glass door type. There's a lot of them out there, but man, I can't believe what you pay for those things. And by building my own, it's pretty easy to make. And you can make one that actually will fit any door out there. So you might want to consider, if you have a dog, doggy doors are wonderful. They really are. Not having one for lately has made me appreciate my doggy doors more. So I'm working on that. That's what I'm working on. So this is going to be put back to the part to the side. What I'm going to do after my doggy door, I don't know. I'm open to suggestions if you have one. I've been seriously thinking about these, and I'm surprised. I've had this sitting here on my bench for a couple of weeks, 3 weeks maybe. Nobody's asked me about it, which is surprising. So, but that's part of what I may get into, doing some bandsaw stuff so that I can get back doing some woodworking type projects rather than these all electronics. It seems like I've been doing more electronic stuff than I have woodworking. So hopefully we'll do a little bit more of that too, because I think that I like to do a little of everything. So any questions, suggestions, comments, leave them down below. I really enjoy reading all your comments, and I try to always answer them. I don't always, unless there's a question in it. So, but I do read them, and I do enjoy them. If you want, just leave me a comment and just spread a little joy. If you like this video or you learned something here, hit that like button. It lets me know and YouTube know that I'm doing something worthwhile. So, most importantly though, please, foghorn. Yes, it's winter again. So, anyway, most importantly, please come back again, because I'm nowhere near done. Thanks, and we'll see you guys again soon.